everyone, it's my pleasure to introduce our work in database. So it is similar to the last talk. We try to achieve the geospatial data management in database. But now it's a traditional database called the Gpdb. And the claim coming from Gpdb. And in this talk, firstly I give a quick overview of the Gpdb database, and then I'd like to introduce our work and plan on geospatial, especially on trajectory. Then I want to introduce database because it's related to our design of trajectory. People guys, they really like the open source. We have released many products in Apache and BSD license. For example, some guys have used the Redis and Spring. Now we have released several other data management data systems like if you want to do some real-time data search, you can use Fire, and if you want to do some interactive queries, you can use Gpdb and if you want to do some batch job, Hadoop is another choice. Okay. In our business suite, we use Gpdb as a kernel because it has developed for more than 10 years, and now more than 1,000 install base are used in enterprise, and it's been open sourced 5 months ago. So now we can find it from GitHub. Just now I have captured the developing of this database to find that in many commits, about 1 week, we can have about 20 to 40 commits every week. So it's very hot. Also, if you are interested to this database, actually for a code start, you can start from the sandbox. You can download from the website. It will run in VMware, and we also provide through the tutorial. You can just follow it one by one step. You can just use it. Thank you. Actually, we have made a lot of innovation because Gpdb is before 10 years ago we developed the Gpdb based on PostgreSQL 8.2, so it's some old kernel. Now we are upgraded to new kernel, but we need more time. Maybe this year, by end of this year, we can finish it. We can update the kernel from 8.2 to PG9. Okay, because I know that many guys are talking about geospatial, but one group comes from database and another group from the earth science. They are working on mapping, on rendering. But when it comes together, it's hard to discuss with each other. For me, when I was a PhD student, I want to attend some geospatial conference. I find that the guys from database, they know little about the GIS, but they are doing some practical question in research. So let's skip this pages on the kernel of the Gpdb. Okay.
Can you speak a bit louder?
What do you mean?
Can you speak a bit louder?
And here is an example of how to query in Gpdb. If we want to retrieve the price of a beer in Brussels, we can submit a simple query like this. And Gpdb is an MPP engine-based database cluster, so we need to collect the data from different segments. So we need to promote the interconnect between segments will be close, and we to make sure the throughput. So it's not easy. It depends on the optimizer. We can generate the query plan very smartly, and it can reduce some traffic between the segments. Also, we have many ways to loading the data in the database. For example, we can have an example. We can save some hot data in row-oriented schema and some cold data in column, and also some real user data in the file system. Okay, if you are interested in the database, we can publish so much this paper. Okay, let's move to the geospatial. Now we have some plan to develop the geospatial in this open source database, and we have integrated the geometry and the geography and something in game plan. Now we are working on the raster and the trajectory. I'll detail this later. For geometry, I think many of us are familiar with this. I'll skip it. Also, geography, yes, we can perform the query in a database with SQL language and principal point like polygon and something like that. Also, we can retrieve the relation between the data. I think I need to talk about something about the index. Index is in GPDB we are using the GIST index to support two-dimension data type, and it is developed by Oleg and other guys. But I think it's not easy. 2 months ago, when I talked with the data scientist based in Japan, he found a simple query. Speed query will cost him very, very long time, maybe more than 10 minutes to perform the simple query. He said he don't know why, because he have two tables. One is big table, it's about millions of those, and another is a small table, have only 2,000 rows. And if he want to do the spatial join, and he create index on both table and analyze them and perform the query, it still costs him more than 10 minutes. So that means we need to use the index very carefully. In my opinion, there are many cases we need to create index. For example, if your data update in route very frequently, the index will split and merge very frequently, and the database is really busy on this, and they have no time to deal with the query. So one suggestion is you can load all the data together, and then you create the index. That means you need to drop index, load the data, and create index again. So it will be much faster. And also, if you have too much redundancy data, I mean some the value of the column they are similar or equal, so it's not that efficiently to use index. Also, for some case, the function cost is hard to evaluate. The query planner will generate maybe not that good. The query plan. So in this case, maybe you need to control the query plan by yourself. So I think for me, I don't believe the index generated by default by the query optimizer. Okay. Here is interesting. 7 months before I watched the television, I found that they said the ship go from China to North Pole, to South Pole. Yeah. And the ship is just like the number 8, but I thought it's strange why people follow this trace, and I Google it and found that the correct route is just like the right one. Yeah, it's very interesting. So we need to make sure the projection between it. But we achieve the geospatial in the MPP engine. It's hard to achieve this because the SRID, the spatial reference ID, it will be invoked very frequently in the function. But if the SRID are stored on the separate segments, you need to retrieve them frequently from other segments. You need to access the data from the net, from the network. So the function will be very slow. So we need to make many modifications to support the SSID in MPB engine, and also we have sponsored two universities. They are doing some research on this. For example, one is working on the duplicate table. It means we will copy the table on every segment, so to foster the query like this. Also, we support the raster data in dev branch. Get example of the island in China, in South China Sea. In 2 years before, this island is very small. It's just like two houses. Yes, but they just have one building on this island. But now you see it's grow very big, right? They can fly the airport. They set up an airport on this island. And in this case, the geometry is not available, so we need raster to describe the island. We come to some interesting things there. We can analyze some data to by intersection the raster data and the geometry data. Here below is an example. On the left is the temperature distribution, and we also can intersect with some geometry data and to analyze it with some simple SQL query. Also for the data like the point cloud, we can analyze it with some in some raster function. But I think we need to support the point cloud in future in some natural way, not in with the raster. Okay, let's talk about the trajectory. I think many guys are heard about that because we are using it every day. Trajectory is a spatial location of moving objects over time. That means, for example, every guy are using a smartphone. It can record your location as time going. So in mathematics, it's a continuous function, but in practical, it's just maybe a set of data sampling. It have two basic dimensions. One is time, another is the position, and also other dimensions like the speed and the direction, something like that. And the next question is where we can get the trajectory. The first is a taxi. I know in China, most traffic information are generated from the taxi. The company get the GPS from the taxi and generate the traffic. So the government they never sell their data. And also we can use some navigation and GPS encrypted on some animals. That data is used in Australia and from the satellite and from the check-in data from the LXR. They need some multimedia data. They have geotag. For example, if you record some video using Sony camera, or if you take a picture of this place, we enable the GPS and update it to the website. It can find your location of the media, also some page and the video and Wi-Fi. Yeah, I think the Wi-Fi is a good data source for location objects. It's very easy to capture behavior of the objects. For example, I know many web map service. They try to capture the behavior mainly based on the Wi-Fi. For example, if you connect to the Wi-Fi for one or longer time, that means you are staying in the office or you are staying in your home. And if you change your SSID very frequently, you are working in some public region. It's very useful to send you some useful message, and also it's very cheap. Yes. Another interesting is if you are using a cell phone, it will simply your location defaultly. For example, here it's easy to find out your frequent location with your iPhone. So my friend suggests me to turn it off because it's about your privacy. Here is the data about the taxi in Beijing. From this data, you can find out we can learn how to build a smart city with a trajectory if we can name it very well. Actually, we have do some research with MSI, Microsoft research, and we try to find out some traffic congestion due by the awful design the neural networks. We find that in some months they are traffic jams very frequently in this area, but for next year it's hard to find it. Then we find the reason they have built two subway across this region, so it can help us to find out some solution to improve the traffic.
Are you using any machine learning?
Yes. The first we need to class the data to find out some popular region and use some frequent pattern associated road to find the pattern between the nearby region to find out which the transfer pattern is really hard for people. If we need to use some machine learning method. So that means the trajectory not only from the GPS, also can use from other data like the picture and the message we upload to Twitter. Also, we can collect from other RFID and NFC and some sensor. Also, the credit card is another source to detect your location. For example, my wife usually monitor my behavior by looking through the bill very carefully. Yeah. And the trajectory data can be moved in free space in Euclidean and also can be described in some constrained space. For example, we can translate our GPS data, the latitude and longitude into the position of the route network. So we call it the network constraint trajectory. So that means we can describe the data in different space. Before we develop the geospatial in GPdb, we have to do many research on trajectory. For example, in prediction, every morning you maybe you drive from your home to the office from 8 o'clock and arrive at the office at 8:30. It's your pattern. If you give me your GPS data more than 1 month, I can detect this pattern. So tomorrow is Monday. If you start your car, I know you will go to your office with a very high probability. So it's called a prediction. And also we try to make some analysis on the semantic. The GPS data is hard to read, so we need to translate it to some textual domain, like you stay at home for 2 hours and drive to your office. It costs you 30 minutes, then you stay in the office for another 4 hours, something like this. Okay. But we find that existing database, there are many guys are working and they have developed some prototypes, but none of them are achieved in the general purpose database. So I think you really don't like to install two databases. One is a general database like Cloud, like Oracle, like PostgreSQL, and you still need to install this some of these prototypes. So a good idea is we can develop the trajectory as a component of some general purpose database. And good news is that I found the PostGIS have done some job on trajectory from 3 months ago. It's called yes, they have only implemented one function called closest point of approach. It's a classic algorithm in a trajectory map. So we try to develop the trajectory with some easy SQL API to analyze the trajectory data, and here actually we abstract the trajectory into 3 layers. On the bottom, we need to know how to store the data, and in the middle, we need to make sure how to organize the data with efficient way in the MCP engine, and from top, we need to specify the function to query it. We develop trajectory very really different from PostGIS. Is because we believe the data have weight, so it's very hard to load the data into the database. For example, if you have GPS data more than 5 terabytes, you need to spend 1 or 2 hours to load the data into a database. It's very time consuming. So one way is that we need to load the data into a database. Just store data in the GPS log, something in the black box, and we can use the GPF disk as one kind of FDW, external table, to load the data into the database. That's it. So we can query from the database directly. We needed to load the data. GPS data into the database, and it will be fast. And also we can use some other ways like the Gpdb and other tools to load the trajectory into the database. So both ways are efficient for us. And we also define several data types to use in the trajectory query, and the most interesting is a trip. Trip is an intermediate data structure for trajectory. It's just store metadata of a trajectory, and our query will be performed on trip. And the trip is really small, so it's very easy to transfer between the segments of all the segments of the segment plan, and it will reduce the traffic consuming on the interconnect. And also we have achieved this function on trajectory. I want to design. I want to give some demo, but I find that I need more time. Maybe next conference I will do some demo, and I don't have enough time. Okay. Yeah. For example, on the function of different the function different from PostGIS. For example, the distance. We need to consider the temporal constraints rather than a spatial one, so it will reduce really different results as PostGIS. Okay, that's all. Thank you.
Yes, I was wondering, the trajectory report, it's only available in the Pivotal database, because if I understand it correctly, it's like Pivotal is an extension to Postgres.
Yes, it's a good question. I want to do this. I want to, after we release the first version, I will move it to PostGIS. I will detect maybe as a separate component in PostGIS. It's an option.
Okay, so it would be possible if you have, let's say, a smaller data set to just use a regular Postgres?
Yes.
Okay.
Well, why don't you use the M dimension you have in PostGIS already? In geometry you have the X, Y, Z, but also the M, and you can put whatever you want into it.
Yeah.
So just a question, don't you rely on this feature to manage time, for example, in your trajectory?
There are two reasons we don't develop in PostGIS directly. The first, we need to achieve it in Punta. It's MPP architecture, so it's very different from the PostgreSQL. And especially for, I have mentioned 3 examples on difference between MPP script and PG. One is SRID, it has to achieve this, and also the interconnect, and also some other things. It's a major reason for this. And the second is now we need to treat it as a new data model. If we perform develop in a PostGIS, I will be affected by the code style. So we need to we are planning to release it by separately. Then we consider to merge them together.
Thanks.
Okay. I think we can go switch to the next speaker. So thanks again.